my background is right here. This is what I call my street cred slide. I started out in computer gaming in the 90s, so I can't really see the audience there, but if any of you are gamers and you played our games that we created with folks like Tom Clancy and Michael Crichton, science fiction writer Douglas Adams, even Ozzy Osbourne, which I realize I don't have pictured there. That was what I did in the 90s. We also worked in the film industry with James Cameron. I worked on the first Mission Impossible. All of it, though, was taking this real-time 3D graphical medium that computers just started really letting us do in the early 90s and applying it to telling stories like the sorts of stories that you heard Adam and Jan are trying to talk about with Real Spy Comics. Then, at the turn of the century, as I like to say, I kind of climbed up Maslow's hierarchy of needs a bit, had this company called 3D Solve, where I was taking the real-time 3D gaming medium, as I think about it, and applying it to training and education, and primarily in the defense industry, trying to help my friends down here at Fort Bragg. I mean, Liberty, but now Bragg again, right down the street, and doing things like the America's Army Game Project, which we'll talk about here in a little bit. I sold my company to Lockheed Martin in 2007. I spent 6 years there running a group called Virtual World Labs, where a lot of the ideas I'm going to talk about today actually were born. We were working with AI and AR and VR and this new thing called machine learning, which I first discovered in 2009, and we'll talk a little bit about that. So I have been a serial entrepreneur for a while, even a parallel entrepreneur for a bit, where I had this Tanjo AI company that I started in 2014 before it really was on the radar of most people. Was running around holding workshops for like Cisco and Lenovo and very large companies trying to explain why they needed a machine learning strategy. And that's also a part of my team's heritage, is we're always a little bit too early, but hopefully with some of the things we're going to talk about today, primarily because technology is accelerating, I think all of this stuff will be timely. But I did fold Tanjo AI and all the machine learning work we did into this company I now call UltraSim. And the idea behind it is to make the simulation century come alive. So a few topics today that we're going to talk about. We are going to talk about simulation and my 3 decades of experience working with that. Something called the Virtual World Framework. If you haven't heard about it, it is open source. It's a Pentagon-funded thing. We're going to talk about that. We'll talk about the sentient world simulation. If you guys aren't SWS aware, I'll make you aware of that. Let's talk about what happened in that bump in the night just 810 days ago. And I do have a little counter here where I actually continuously count the days of what happened on that day, that bump in the night. If you're familiar with the idea of the singularity, I don't really think that was the singularity when machines exceed human intelligence and everything changes, but I do think it was a singular event, and we're seeing how fast things are changing. And I want to talk about the role of that technology in the simulation century. Digital twins is part of the discussion, and then modeling humans, making digital twins or synthetic population models of entire countries. And what does that mean for the intelligence community? And of course, finally, how do we prepare, recruit the intelligence community of the future? What skills are they going to need in addition to the human skills that you heard about from Adam? So first of all, this idea of the simulation century, I've been holding an event at what was Joint Forces Command. It's no longer a command, but if any of you are from that area, you're familiar with the area, in Suffolk, Virginia, we started holding these sort of events as part of Mod Sim World, talking about this subject of simulation, AI, and the intelligence community of the future. But the core idea behind, or the thesis behind the simulation century is that, and by the way, I'm a liberal arts guy, although I am a technologist, taught myself to program and all that years ago. But one of the people I really read a lot about back when I was in school was this Canadian guy named Marshall McLuhan. Hopefully all of you are familiar with him. Marshall would say things like the medium is the message, or the things that we make us. But he said that the last century was about the recorded image. So it's the first time in human history when we could review video footage of current and recent events and have conversations about it. And he would say that that medium that we used to contemplate those events actually changed us physiologically, changed us culturally, sociologically. And now I'm saying that this century is about simulation. Again, first time in human history when we can use things like this amazing compute power we have today, GPUs and CPUs, incredible storage, networked together with the internet, and now AI and machine learning to not just model what happened before and look at it and talk about, all the complexity of what's going on in modern life or what's happening currently with digital twins, but we can also go into the future now. We can time travel backwards and forwards and actually predict or attempt to predict what's likely to happen. But as you'll see as we go through this, one of the things I really believe is the highest moral purpose of all of this technology is not just predicting the future, but designing it and enlisting the forces of AI and all this technology to the goal of actually building the world that we want. So we'll talk about that a little bit. But you can see some of the people that I would invite, and I was like provoking that audience instead of having the normal list of Beltway bandits and people from Lockheed and Booz Allen and that sort of thing. I would bring in the producer for Dr. Dre or Charles Simonyi, the guy who's standing on my right there, who invented Word and Excel and was one of the first Microsoft billionaires, and really try to bring outside ideas in and stir things up. Because I do think perspective is worth 80 IQ points, as our friend Alan Kay says. But again, simulation to me, the virtue of it, the big virtue is that it is a really powerful medium. And games are some of the best simulations out there. That's again where I got my start. I believe that all games are simulations, but not all simulations are necessarily games. Just something to keep in mind. But it is a powerful medium, and that's how we're going to talk about it here today. If you want to understand a complex system, you have, it's helpful to be able to model it and simulate it. And with this medium, you have every media type ever used before in human history. So you've got text and speech and sound and, of course, video, and now completely immersive 3D environments and characters that are becoming increasingly convincing. So that, again, is the heritage of my team over the last couple of decades. Another big thesis statement, I'm really big on these thesis statements, is that and I've been saying this for many years, you can see some of the articles I wrote. This one's in TechCrunch back in 2014, but I've said that the most important issue of this century is to figure out the right balance of humans and machines to optimize outcomes. I believe it doesn't matter which industry you're in. So I've written a lot there about superhuman education and superhuman healthcare, and now we're talking about superhuman intelligence operations and that sort of thing. I believe that it's now insufficient to be a standalone human being. So think about that for a minute. It's been true for a while that if you've got a smartphone and you're really adept at search, you're arguably more intelligent and more capable and able than anybody else you're working with or competing with. And now I believe that those who harness the powers of simulation, which includes AI as a subset, are going to be more powerful, more capable, will outperform those who don't get that balance right. And it's a critical issue. So, and again, for me, simulation includes AI, machine learning, as well as the visual media and all the other media types we're talking about. So again, I just want to tell you very quickly about my journey and how I got religion on machine learning. It started all the way back in 2009. Again, for most of the people out there today, and I know many of you are technologists, so this is probably true of you as well, you probably were aware of AI and machine learning long before this bump in the night of 810 days ago. But for me, it was 2009. I was working at Lockheed Martin, running virtual world labs. We had over 100 patent disclosures in my 5 years or 6 years there. But that's me with Alex Kipman, the inventor of the Microsoft Kinect. And for those of you who had Xboxes back in the day, that was the device that was added onto it where the human body could become the input device for games, if you remember that. And then the guy on my left shoulder there is Jaron Lanier. He's the guy who came up with the term virtual reality and is also a really interesting philosopher and musician and guy to hang out with and talk about crazy ideas. But what we did there is we actually were trying to teach this system using this brand new thing called machine learning. So this is the first time I'd seen it. And back then, we really didn't have a lot of good tools, not a lot of libraries. We didn't even have really good GPUs yet, except for on systems like the Xbox and the PlayStation. And it took over 224,000 hours of CPU time just to teach it, the difference between a table and a lamp and a chair and a cat and a dog, and how to recognize different people when they walk in and how to track the motion of our arms and hands and all that. So it was definitely a different time, but that really blew all of our minds. Not only that, the important thing about that device was that it had these sensors on it. And that's why I was there actually from Lockheed, is just to help with the sensors. But it could see into your living room, it could hear, it was recording all that, and it was processing it with its machine learning brain that's on the edge. And by the way, the whole brain for that system was about 60 megabytes because we'd already shipped these systems all over the world. So whatever we did had to fit inside of that, less than 100 megabytes actually. But I would unplug it all the time, even after I had them in my house and in the office, because I knew what it was doing. It was seeing, hearing, and processing, and then sending data back to the mothership way before Siri or any of that. But that showed me that there's, it was, for me, it was a new button on the calculator. It was the new scientific method. It was a new way to solve problems. I brought that back to Lockheed and we started working with that technology right away. Now, one of the things that happened not very long after that was, of course, Lockheed Martin is a national security company. So occasionally we would have someone walk over in Bethesda, Maryland to our offices there and say, hey, there's a big, huge issue. We need you guys to look at it. It has national security implications. So we looked at things like the escalating cost of healthcare and a bunch of other issues. But this is one that really I found interesting, where we were tracking how AI bots on trading indices were starting to trade with each other. So this was about, if you're seeing the bottom down there, it says 2008. These are bots trading with each other. There was no SEC tracking of this. There were no regulations about it. Not until Michael Lewis wrote his book, I think a year or two later, did the SEC get involved and actually start looking at this. But when I saw this and we looked into the research on it, I actually fired my financial planner, I think that day, because I said, dude, you can't help me anymore. You're a standalone human being, and this is the future. This is happening at the speed of light. And not only that, we actually caught these systems trading with each other in the future, only microseconds in the future, but measurably 190 milliseconds into the future, they're trading with each other. And so that means that even if you're a human and you figured out, oh, I got to have some AI helping me in my trading desk, it's not enough for you to have that and be in Toronto or be in Yonkers. Because this is happening at the speed of light, you want your really powerful trading AI algorithm on a really good substrate to be as close as physically possible to the other machines that you're trading with on Wall Street, ideally in the building next door, because everything's happening at the speed of light. And this is the world. For me, that was the future shot back in 2011 that said the world is going to change and we've got to really start adapting to it. This is just another structure for me of how I think about this progression. Like I said, AI and machine learning have been around forever. We've even had back propagation and machine learning systems going back to the 60s. And of course, AI is an idea sort of emanates from 1958. But 2009, I have that in red because that's, for me, like I said, when everything changed and I started walking around viewing the world differently. And from 2009 to 2018, I couldn't find enough data scientists, right? We're always looking for data scientists. As you know, they're still in high demand. And then I said, from 2018 to 2022, it was about prompt engineering. And, because 2017, if you were tracking that, is when that first white paper came out that said, the title of it was "Attention is All You Need." And those of us who are working in the industry, that's when we first got that paper and read it, started building our early chat bots. I was just wondering if anybody there remembered or knew about the very first transformer that we could use as a chat bot that came out shortly after that white paper. It was a system called BERT, B-E-R-T, bidirectional transform. That's what all of us in my group that we were using to build our bots to talk to data. We had to figure out how to prompt and guide these systems. So BERT came first, and then ChatGPT 1, then 2. And I have to say that we'll get into some of that stuff of how I was using those systems, but it wasn't very satisfying. And that's one of the things that's very important to understand about machine learning is that, or is really driven by something called a utility function. The utility function is what you're giving it as its reward mechanism. What do you want it to do and how do you reward it? And that's the activity you get from it. So I believe that today in a lot of these systems, whether it's DeepSeek or Quen or ChatGPT, they all have residual utility functions in there. One of the biggest ones that we were all screaming about years ago was please the prompter. And that's why it tries to make up stuff and why it hallucinates, is it doesn't, because anytime I would give a blank response, we would all complain to the programmers about it. But more on that later. But we're going to talk about where we are now and what does this man-machine, human-machine sort of combination look like. the symbiosis, and then how does that fit with the simulation model of the world? So for many years, I think starting in 2010, I would go to these singularity conferences. And again, I can't see you guys, but if you are familiar with the idea of the singularity, it was by a science fiction friend of mine named Werner Vinge actually came up with it first. He talked about the technological singularity. And the idea is the minute we make an AI that can improve its own database, that's an important part. The minute it exceeds the capacity for human intelligence, that's the last invention we're ever going to have to make. So this path to artificial general intelligence, as my friend here, Ben Goertzel, who I met at one of the Singularity conferences with Ray Kurzweil in 2010 in Manhattan, is, you need all of these components. So many people are still very excited about large language models and prompting, but for all of us who work in this space, that is only one component of what's really important. It's amazing how the natural language processing really broke through that threshold 810 days ago, because it surprised even all of us who've been working with it for a long time. But what we're forgetting about is this thing called the knowledge graph. And that, in the old days, we would call them ontologies. We would work with systems like OWL. But even when we were trying to build the thing for the Microsoft Connect, or other work I did for the Library of Congress and for the Department of Education, something called the Learning Registry, well, we were trying to map everything that was in the Smithsonian and everything in the Library of Congress. You needed to have some sort of semantic model for your AI to converse with and update and store its understanding, its models of the world. And then the last bit is just like with my Microsoft Connect. If you take those two powerful components and connect them to something that can actually sense the real world the way we humans learned about the real world, by interacting with it, by sensing, hearing, tasting, and then updating our models, our knowledge graphs, and updating our intelligence. If we connect all of these things together to the real world, to a digital twin of the real world, my sort of thesis here is that that is the path to AGI. And Ben Goertzel would agree with me. My friend Doug Lennett, who unfortunately passed recently, who created Psych, also would agree. So I do think this is how all that's going to happen. And I did go 15 months now, went to DC and did the requisite tour of all the congressional offices and Senate offices on the committees, and did my little 30-minute briefings. And this was basically what I briefed everybody about. But one thing I'll tell you is I started every one of those briefings by saying, how many of these have you already had? And usually they would say, 10, 12, something like that. Then I would do my little 30-minute song and dance about what I thought was important, what they needed to know as they crafted policy around this technology. And at the end, I would say, did you hear anything new that you hadn't heard from the other presentations? And in every case, they said yes. And that was very concerning to me, because things like this one that's in red, I've tried to explain to everybody in government, going back to when we did some of the first contracts in AI, where I was licensing my machine learning system to OPM and to GSA and folks like that, trying to get authority to work on government networks, that kind of thing. We had to start by saying, this is not like regular enterprise software. There is no debugger. Like you can't go in. Sam Altman and his team, or Elon Musk, and nobody can go in and actually see the code and understand what it's doing. We don't know, right? It's just we humans are building systems that are 10,000 times more complex than our conception of them. We can't control them. All we can do is do the inputs and then see how they perform against reality, and then go back and retrain them again. So that's an important idea that should shake everybody who's trying to treat it as if it's, oh, we'll just go buy some software. It isn't like normal software. The other thing is model collapse. And anytime I'm on, and I have a slew of these little speaking gigs where I get paid to go and talk to different audiences about this kind of guidance, both in the DoD and in commercial environments. And it always troubles me if I'm on a panel and I look around and I go, how many things have you built? How many have you built? And it's just a bunch of people who are really excited about large language models and doing prompt engineering. Whereas, I've built a lot of systems for banks, for a lot of different companies, and within government, where we trained it ourselves from the beginning and deployed it. So we have witnessed this thing called model collapse, and that's something we're all watching for. And we've seen a little bit of it. I'm not sure how much press it's getting, but if you keep having systems like DeepSeek was trained on the outputs of ChatGPT, right? OpenAI. So every time, and this is important to understand too, is that I think I have it in here somewhere, these systems cannot exceed their own database currently. It's not how they're designed, not the large language model portion of it. So that means that if it's trained on everything in Wikipedia and whatever it has access to on the internet, that it is a lossy compression of that data. And then if you keep training on those outputs, you lose something every time. And, eventually you get what's called mass forgetting and the whole thing just sort of crashes. So that's important to know. But again, knowledge graph's really important. Hooking up to the digital twin, very important. This is an article I wrote in Design News talking about these stages. And the one that I'm really worried about is sort of stage 2, where, and many of you have probably seen this, especially in academia. It's when, and I see that even with people that I work with or some marketing PR firms that I've worked with, where they lean too heavily on these capabilities and they produce a bunch of content and they hand it to you and you start going, oh, this is really interesting. Then I ask you a couple of questions about it. And as you start asking questions, you realize they can't answer questions about the thing that they supposedly produced because they haven't internalized the understanding. They haven't updated their own internal models. So effortless content creation is a problem. So something to keep an eye on. But again, I talked about some of these things like automation. That's something everybody should be doing. I think every company should have, and I think that's true in the intelligence community as well. It's that balance, right? Of what should humans be doing with their effort, their intelligence, and their attention, those three things. And what should you turn over to machines? Because it's ridiculous for humans to be doing that activity anymore. I think in the realm of intelligence analysis, again, really, really insufficient to be a standalone human being. I have gotten into some conversations with people in the intelligence community. Like, I mean, even I'm sure Adam would say, like, there is no substitute for that human to human connection on the human side and that cultivation of the relationship. I believe that's actually true. But looking at raw intelligence about, like, how do I pull the signal out of what's happening in the world with potential cyber attacks and other kinds of activity, I think giving a lot of that over to raw machine intelligence that has really well crafted utility functions is incredibly critical. And then human intel folks who are trained to work with those systems and to guide those prompts, those utility functions, I think is going to be a critical need. But we'll see as we go. But as I said it earlier, I think the highest moral purpose of it all is, what kind of country are we trying to build? What kind of world are we trying to build? What are we trying to do in Canada? What are we trying to do in the US? And I'd like to see more politicians now showing up with, I want to see debates about, like, here's my simulation. Here are the inputs. I want to do Build Back Better. I want to do the CHIPS Act. I want to get rid of USAID. If that's what you're saying, it's like, okay, you have these, obviously you're doing those things for a reason, but can you show us the simulated world you're trying to create? Who wins and who loses? Can I run that simulation and see that? So I understand why I should get behind the things that you're doing instead of just putting blind faith into what people are doing. I think a debate should be, here's my well thought out simulation. And you can question the data that goes into it or the functions on that data that give me the outputs, but at least there should be a model that I can interrogate. And if I'm showing up with my simulation and the other person doesn't even have one, why in the heck would you put your vote and your money and your persona behind that person who has no idea what they're doing? They're just pulling levers with no idea about what's going to happen. All right, I'll get off my soapbox about that. But yeah, a big subject that we're talking about here today is the workforce of the future. I was on North Carolina. I was appointed by two different governors, a Democrat and a Republican, to be on the board of trustees of Wake Tech, which has about 70,000 students. First time I toured it, and I looked at, things like radiology and some of the things that we were actually teaching there. I'm like, even 8 years ago, I was going, why are we still teaching that? That's not going to be a job soon. And that's really the lens we need to be looking at things. Anything that can be automated will be, and the most you can expect to be paid is the cost of renting the machine. If you're trying to do a job that a machine can do way better, machine learning systems are way better than any human radiologist. I think doctors diagnosing things and all that is going to go away very soon. But this is the more critical problem to all of our societies around the world. And I know they've talked about it at the World Economic Forum and a lot of places, but it's this age-old battle between capital and labor, right? And capital is winning big time because, again, you can just build machines that do things that humans once did. And it's not anymore just about, mechanical things and replacing human labor with a machine, but it's also, like I said, the analysis, the attention, all that stuff now can be replaced. The sort of difference is with the Industrial Revolution, we had 200 years to adjust to this encroachment of physical automation in our factories and in our environments. So right now, 200 years ago in the United States, I think 91% of everybody in the US was involved in agriculture. In 1900, it was 40%. Today, it's 2, right? So we found other things for people to do, but the difference is now it's all going to happen in about 15 years. So we don't have 200 years to adjust. We're going to have to move a lot faster. Back in 2015, Ash Carter held a Force of the Future war game. I was on the red team for that, along with Alan Kay, a guy from Xerox PARC, Doug Lennett, who I mentioned earlier, who had his Psych system, Michael Jones from Google, who created Google Earth, and my colleague from Lockheed Martin, David Smith. And one of the things we found in that is that the Force of the Future is we'll need about, half to, in some cases, I think, a third of the human soldiers that we need today, but each one of them will have 20 times the strike capacity. So what does that mean? Because we're going to give them all the powers of hell, all these different systems that we're building. So what does that mean in terms of recruiting and training? Well, the outcome of that war game at that time, without going into all the great gory detail, was that we need to recruit and train the way we recruit and train fighter pilots, which means really be careful about how we select them. They've got to have extraordinary emotional intelligence, IQ, quasi-engineering capability, and they have to be really mentally stable. Like we got to select out for any of the isms, because it doesn't work well if you're going to give someone, just all the powers of hell, like I said. So that was the outcome of this. Is it's going to be more expensive to recruit and train, and we've got to be really very selective. So let's talk about digital twins just for a second, and then we'll get to the human modeling part of it. So this is another thing. There are 2 reasons why Lockheed bought my company in 2007. One was that I'd created a digital twin of an entire submarine. I saw that we were setting aside, $1 billion submarine just for training, and just said, that's dumb. Right? We don't need to do that anymore, because I can build with my powerful gaming simulation medium. I can build a really high fidelity 3D model. And by high fidelity, I don't just mean the graphics. I mean that I can have 3,000 sensor systems, the hydraulics, the nuclear propulsion, everything faithfully represented in a simulated model. And I can build a multiplayer simulation where all of us can go in there and actually perform our roles, the complex choreography for getting that thing underway. And that was a game changer, right? Because now you don't have to set aside a submarine. People can be sitting wherever they are in the home station, and they can train faithfully, even with people that are working with the real equipment in the field. So this is something that's become core again to my team, is the ability to build these data-driven, sensor-driven, high-fidelity simulations, where we actually came up with this term, the simulation equivalence principle. And I'll make sure Robin gets you guys a copy of the paper I wrote about that I presented at a couple of conferences. But the idea is you should not be able to tell the difference between simulated input or real world input when you're actually in that simulation. When they're crafted architecturally the right way, that is what you get, and you can do high fidelity training and preparation and readiness in those environments. So here's my submarine, and I won't really drag you through it, but we did it in the Unreal game engine. I think it says 2005, so a long time ago, and you're looking at the unclassified auxiliary engine room part of it. But again, it was I as the dungeon master, if I'm training, some Navy personnel in this, I can actually start fires, start hydraulic leaks. And if you go and turn that valve, 1/3 of the way open, and you're sitting in Toronto and I'm sitting here in North Carolina and I'm manning a gauge, I would see that gauge do exactly what it does in the real world. And so that, again, is just a game changer in terms of having a software simulation. That means I don't have to travel anywhere to train. I can do extra reps in a safe practice environment to hone my skills, whether it's landing an airplane on the river or working in a submarine or running a McDonald's restaurant or whatever. The other thing we did is we did a complete digital twin of a brigade combat team and all the business rules and data that went into that. And this is one of those early examples of, there used to be at Fort Monroe, Virginia, there was a group called the Architecture Integration Management Directorate, whose only job was to analyze a lot of business rules and information, especially in the joint environment. If I've got different rules from the Navy, Air Force, Marines, Army, and I'm trying to reconcile all of that and say, can I do this thing? Can I do this movement plan across Afghanistan? And how do I make sure my communications stay solid so I don't have friendly fire incidents and things like that? They would spend hundreds and hundreds of hours of analysis trying to decide if they could do something or not doctrinally. And it's the .MLPF. I still remember, it's burned into my retina now. The department organization, training, leadership, personnel, materials, and facilities rules from each of the services for each thing. And we built a system not knowing any better, back then that would, and it was a lot of the old AI. It's what today people call compound AI, but it's really just the old AI was just business rules and finite state machines and logic that was kind of hard coded, and then with the adaptive machine learning capability as well. But we gave them an ability that again have this 600x improvement over previous things that they were doing. And Fort Monroe no longer exists. Like they got rid of the fort. I'm not saying we made that happen, but they're not doing that job anymore. So one of the things we also did, and I'm going to go back to that sentient world simulation. When I was at Lockheed, we were modeling we called it psyops back then. I think that term isn't as popular now, but really what you wanted to understand is hearts and minds, or if you remember that in Afghanistan. So modeling all the people in Afghanistan, and we wouldn't say, here's 4 basic non-player character types. There's Sunnis, there's Shias, there's Coptic Christians, there's whatever, right? Instead, there would be hundreds or almost 1,000 meaningfully different cultures, values, traditions, whatever was important for us to actually track. We had modeled that like we would a game character, right? In things like WarSim and JSim and a lot of these constructive simulation models that we had, including what ended up being SEAS, which came out of Purdue University. We would model this and then we'd say, if I go and build a school for girls in Helmand province, show me all the different groups of people and how they feel about this action. Usually it surprises you because you go like, well, this seems like a really good thing. School, right? We're going to build a school. USAID is going to come in and build a school. Well, you'll see that there are people that are really happy about it. Some people are neutral, and then people that are really red, and they're going to so much so that they're going to set it on fire and they're going to shoot Malala. So at least you're not surprised by any of that. So again, fast forward a bit, and now we're getting into digital twins of humans, and what does that mean for the intelligence community? So I met a couple of these folks here. So that's me with Kevin Clark from IBM, Dr. Richard Carson from UCal San Diego, Dr. Jordan Louvier from University of Washington, who come up with a lot of the models for like, how do humans make decisions about things? A lot of this was about market research. And again, I looked at this and I said, hey, I just come out of this world. We modeled everybody in an entire country and could figure out with pretty degree of accuracy based on the intelligence models of how they're likely to react to things we do or don't do. But market research was still like, there's 2 ways to buy cat litter, or there's 4 ways to buy chicken, or that was still the state of the art. Well, what we did, and this is one of the books that they had me read, and I know you have to deal with this a lot in the intelligence community, is that everybody lies. So how do you understand and how do you get to ground truth, right? The way people were doing that is in market research was focus groups and surveys, right? And we said that's not a good way to understand who people really are. The best way is to look at what people do with their attention and their money. That's who they really are. Like focus groups did not predict Donald Trump being elected in 2016. It didn't predict Brexit. What did is what they're doing online and what they do, and also location services, how they move around and what they do with their money. So we built this model back in 2017. We got a Gartner Award in 2018. We took a whole bunch of Nielsen data and we started making these synthetic persona models or synthetic population models of people, and started doing it for Procter & Gamble and Kimberly-Clark and Pepsi and all these different companies, and showing them that having the little Sims world of your customers is way smarter, more cost effective, and more accurate than doing focus groups and surveys. But it all comes down to how good is your data. And notice that I never say 100% because humans are not automatons. If you're a really predictable person, then I can predict you with a high level of accuracy. If you always eat a tuna sandwich on Wednesday at this one place, then I can predict with a high level of accuracy where you're going to be at noon on Wednesday. But most people aren't like that, right? We're driven by other noisy sort of influences. So that became problematic when we won this contract years ago with this company called NCI, and Tanjo was my company at the time. So we ended up modeling all the world leaders. And so the idea there is if you really have a lot of data about what they did in the past, when faced with different situations, you ought to be able to put that into a computer simulation model to see how they're going to act in future situations. So, and also, how do you influence and pull those levers to get the behavior that you're looking for? Now, this program didn't work very well. Like we did the model for it, but I didn't get to put the data in. That came in secure environments, TSSCI level environments. And what I heard, I got called on the carpet at one point being told that our Vladimir Putin model was not performing well. And I'm like, well, the model works, but how complete is your data set? If you have an incomplete data set, or you're not accommodating for the fact that like a lot of these models just say, well, here's this point in time, and everybody thinks like this. It's like, well, no, there are influences on people all the time. So we have this idea in computer gaming called state change, or what's called hierarchical behavior trees. If you want to make realistic, convincing characters in games, and you're going to see a lot more of those coming very soon, they need to have that functionality, which means that in different states, if they're feeling favorably towards you or angry towards you, or they're generally feeling unease or confidence, their whole decision tree and state actually changes. So that has to be in the simulation. I showed Robin, this was in the Toronto Globe and Mail, I think 2 years ago, but my dad died in 2017. And at this point, I'd been hanging around with Ray Kurzweil. And of course, if you know anything about Ray, he's really very interested in resurrecting his own father who died a long time ago. And so he's got a big room full of all of his records and his correspondence and that kind of thing. But when my dad died in 2017, he didn't have a Facebook profile. He wasn't on LinkedIn. And I scanned what I could, everything I had of his military records and correspondence and what I knew about him. And the rest of it I did the way I would my game characters, which is hand enter, or the way you do in human intelligence, say, which is hand write, like, here's what I think. My experience of this person is the following, and here's how I believe they would act in these different situations. But I was able to have conversations with my dad way back in 2017. I ended up doing a speaking tour of South America, and there were cultures there in Buenos Aires and Medellin and elsewhere where they were really urging me to create a whole business around allowing people to talk to their ancestors and get advice on, should I marry this person? Should I take this job? Should I move to this new city? I just never got comfortable with the business model on that. And I said, someone will do that, but I'm not going to. But can we do it today with increasing levels of fidelity? Yes. But especially since if you have someone who has a really big footprint out there of social media, and not only the social media part, the best predictor, like I said earlier, is what you do with your money. So the best data I've seen comes from banks. And so the work I've done for banks, like, I shouldn't mention the bank names probably, but I'll just say that when we built our systems for them, they would be on standalone machines with a $3,000 NVIDIA card in it. We put some blinking lights on it and make it do some whirring sounds. So it would look like it was doing something, but it would be in a room not connected to the bank's network because they didn't trust it, right? And they understood everything that I said earlier about how powerful and unusual and intimate these systems are. You don't want to be using them as software as a service over a network where you're uploading all your stuff. Like that's just really bad practice with these technologies. But having it contained where you control how you train it, the data that you're getting, and they actually had a thing where you had to go in there, you could only access the machine with a USB, and there had to be a person observing you while you did it. So it was like working in a skiff. And that's the right way to handle this technology. But those financial things are really predictive of who people really are. That with location services, not so much social media, to be honest. So these are some of the things we're doing today with our chatbots. So ours are, it's not just text-based, but we have to have our game characters. And we did try to experiment with, and I'll just jump ahead to show really high fidelity, Unreal game engine characters that get right up to the uncanny valley and really cross over. But we found that people got too distracted by trying to pick out like, oh, that lip did move the right way, or the eye, had a strange look to it for a second. So we sort of rolled back to these kinds of things. But the important thing is this right here, which is that sort of sentiment model, along with they can speak in different languages, but I can have conversations with them. And if we did a journalist game where if I'm interviewing somebody and I'm asking the right questions, or I approach them the right way and I bought them tea, or whatever it was, took my hat off and my glasses off when I'm talking to them in Afghanistan, then their comfort with me grows and they open up and they share a lot more with me, right? And I can actually see that programmatically as I'm learning how to do some of the things you heard Adam talk about. Like, how do you build trust? Am I building trust? Am I reaching them on some level? And how do we build sims that help us do that with these technologies? Forgot I have this in here, but yeah, years ago we did one. Again, if any of you are gamers, this was 1997. So way before any of this chat stuff, we built a system called Spooky Talk. Actually, we called it Velocitext. Douglas Adams called it Spooky Talk, but it was in the game Starship Titanic that lets the player actually have conversations with game characters. And you still don't see that today. So it's another example of how we were way too early in some of the work that we did. This is another important idea. So in 2016, I was part of this sort of working group with the Pentagon that was hastily put together after Cambridge Analytica to say, like, how did these influence campaigns actually happen? And the example I have on the screen here now is one that's, I think, a little more benevolent. But what we learned from that is that it's surprisingly and shockingly easy to get someone to move from a core belief to something entirely different through an influence campaign. So if I can reach someone in this example of kale, again, if I was there in person, I'd say, how many of you were eating kale 10 years ago? Probably not a lot of hands went up unless you were German. But in the United States, for example, the biggest buyer of kale back then was Pizza Hut. And it was for putting on the ice around the salad bar because it doesn't wilt very easily. But nobody was eating it. But the Kale Growers Association hired this group and said, hey, how do we build a market for kale in the United States? And in a very short amount of time, they came up with this model, which is micro agreements over time. And again, Adam, if he was on screen right now, would probably be nodding, going, yeah, that's what I have to do when I'm trying to win somebody over, right? I start with dark green vegetables are better for you. But kale tastes terrible. Oh God, I'm at stage 2 here and I have micro agreement. So now they're nodding their head. They're agreeing with me. And then I say, oh, but Rachel Ray has a new cookbook out that makes kale actually taste better. And by the way, here's some influencers of yours, Gwyneth Paltrow or Oprah or Donald Trump or whoever that is repeating some of these things. Next thing you know, people don't even remember how they got to this new position, but now they're walking into a restaurant demanding kale for $15 a plate that's been massaged properly. That happened in a short amount of time. So that's a benevolent example. But what if you're trying to affect an election or get people to behave a different way during a pandemic? So we used our technology to do this synthetic modeling in the United States as part of the Pandemic Response X Prize Challenge. We were a finalist for it, and we modeled all 3,000 counties in the United States. And we were already doing that, as if you recall, in market research. But every time I did another thing, whether it's chicken or travel or how people buy tuna or whatever it is, the models just keep growing and building about what kinds of people who like this also like that. People who move in this sort of way or get their news from these environments and these influencers think this way. And the models just keep getting more and more robust to the point where we could predict infection rates in every county in the United States based on who lived there, where they're getting their news, where they're getting their information, who their influencers were, how that translates into probability of movement, probability of wearing a mask, how many hospital beds are available in that environment. So there's a really valuable simulation capability that, thanks to Dr. Carson and some of the folks who worked with us on this, we were outperforming Johns Hopkins in our infection rate predictions because it comes down to, it's not just about SEIR models, it's about what's going on up here with human minds. I'm just going to show you this quickly. This is a very simple model, but this is representing everybody in a county. I've got them grouped into 10 high-level groups, and in the middle there's like 100. Every one of those dots is a group of people. Let's say it's another 100 people. And then what we show you at the end is there's some different views here. This could be Democrat, Republican. It could be Coke versus Pepsi. In this case, it's government shouldn't tell me what to do, and I'm going to do what I want and move around. And then the other one is, take safety measures, wear your mask, don't move about. And then we've showed that if you have different people repeating that, if it's an influencer who has impact with that person or that group, you'll watch them move a lot further towards the extreme. And we can do that for a lot of different subjects. Like I said, Coke, Pepsi, Democrat, Republican, fascist, communist, whatever you want to do. It's a really interesting sort of exercise, but also unsettling, like I said, with how easy it is to do. We built a system that simulated all of the state of Washington. I know I'm probably running over, so I don't want to go too deep in it, but this capabilities exist, right? So we can build these little sim worlds and understand like what's happening, what's affecting people's behavior, and what can we do to get the behavior we want. Now, obviously, like any technology, it's incredibly powerful, very intimate, like we've described here. It can be used for good or it can be used for not so good. It can be used to get you to smoke more or eat more kale. Here in the US, the IRS, for example, has an RFI or already had it out. I understand Booz Allen has won this, where they're building a little sim thing of the United States just for the IRS. And the stated purpose is to help us pair us better with the tax preparation capabilities we need. But we all know that's not really what it's about. It's looking for waste, fraud, and abuse and that kind of thing. Here's the DoD Virtual World Framework. There's a link here, and I think Robin will give you guys the whole presentation, but it is open source. So anybody can use that thing which we built, which started with the sentient world simulation and ended up being a Pentagon program run by this guy here, Frank DiGiovanni, D9, we call him. My colleague David and I won that contract. We built that system. It works, and you can do everything that we've been talking about in here and I think that's just about my time. So again, how's this stuff are we gonna to emerge with artificial general intelligence. It's these three components coming together. Then I have a bunch of books. I need to put Tom Barnett's books on here too, and that's my time.